They're playing basketball
all around the world. To the beach, y'all. Let's go. All around the world. Y'all know this is so that. To the beach, y'all. Yeah.
Basketball is my favorite sport. I like the way they dribble up and down the court. I keep it so fresh on the microphone. I like no interruption when the game is on. I like slam dunk to take me to the hoop. My favorite play is the alley-oop. I like the pick and roll. I like the give and go. And it's basketball. Bow wow, let's go.
All around the world. Yeah, to the beach, y'all.
In my hands, ain't no telling what I'm gonna do with it. When I got possession, I'ma act a fool with it. I might cross you up and fake one way, turn around and hit you with the MJ fadeaway. I'm throwing down passes like J Kidd, taking catch to the rack, and I'm dunking on them like C-Mac. When I'm in the plane, I play with that Alonzo style. I'm like Darius, cause I can
Don't too many players get offers like me. Back and forth are likely.
It may not mean nothing to y'all, but understand nothing was done for me. So I don't plan on stopping at all. I want this forever mine, ever mine, ever mine. I'm shutting down in the mall and telling that girl she the one for me. And I ain't even planning the call. I want this forever mine, ever mine, ever mine.
Last name ever, first name greatest. Like a sprained ankle, boy, ain't nothing to play with. Started off local, but thanks to all the haters, I know G4 pilots on a first name basis. In your city, faded off the brown. Nino, she insists she got more class. We know, swimming in the money, come and find me. Nemo, if I was at the club, you know I balled. Chemo, dropped a mixtape that sounded like an album. Who'da thought a countrywide tour be the outcome? Labels want my name beside an X like Malcolm. Everybody got a deal.
Hey, Gossam here. It's what's up, Mustang? So anyway, we're going to talk about system of equations. We're going to talk about it in a few different ways. I'm going to go over the equal values method. First of all, I just want you to realize and think when we have the y equals 3x minus 2 and y equals negative x plus 2. Those are two different lines. So one of them is a positive slope, the 3x, and one of them is a negative slope. So eventually they are going to intersect at some point, and we're trying to find that point, okay? And that's going to be the solution to the problem. So when you have two lines, when the lines are equal to each other, that means that would be the solution where they're equal, that one point of intersection. So what we do here is, since we have y equals this and y equals that, y does equal y. Okay. So if that's the case, we can say, all right, the 3x minus 2, all right, 3x minus 2, that's the first y. The second y is negative x plus 2. So we set them equal to each other. That's what you're doing. So essentially you're just saying 3x minus 2 equals negative x plus 2. And you're going to see where do they intersect. So it's just back to solving for x when you have x on both sides. So I'm going to add x. So what does that give me? 4x minus 2 equals 2. I'm going to add 2. So I get 4x equals 4. And then you divide by 4. X equals 1. Now, if we are finding an intersection, if we are finding a point, we have the x is 1. We need to find what the y value is. So how do we do that? Well, you take your x and you plug it back into one of the original equations. So what I'm going to do is I'm going to choose y equals 3x minus 2 because I don't want to have to deal with negatives. So that's what I'm going to choose. So I'm going to plug the x in. So what happens is you have y equals 3x minus 2. I'm going to take the x. X is 1. So if x is 1, you substitute that in. And 3 times 1 is 3, minus 2. So you get y equals 3 minus 2 is 1. So where do these two lines intersect? They intersect at 1, 1, and that would be your solution. And now you know more.
Hey, what's up YouTube? Mr. Hart here, and now we are going to still solve a system of equations, except we are going to do it with a graph this time. So we use the same system of equations, same two equations that Mr. Gossam went over when solving it algebraically, but now we're going to do it on the coordinate plane. So whenever we graph something, we first need to know what is our m, what's our slope, and what's our b, what's our y-intercept. So for my first equation here, y equals 3x minus 2, my m is 3, and my b is negative 2. So if we want to graph, you first need to start at your b, your y-intercept. That's the one point you know for sure. So on the y-axis, I'm going to put a point at negative 2, and then I'm going to use my m to figure out what my next point is. Now, since my m is just one number, and I need it to be rise over run, I'm going to make it 3 over 1. So since it's positive, we're going to go up. So we're going to go up 3, 1, 2, 3, and then right 1. Remember, always go right for that first point. Positive and negative just tells you up or down. So then we can go up 3 over 1 again, up 3, right 1. Because I'm trying to figure out where are these two lines going to intersect, for my first line, I want to take up the majority of the graph. So to put some points on the left-hand side, we're going to go down 3, left 1, down 3, left 1, and then I'm going to draw my line connecting the points. So now, since my goal is to figure out where do these two lines intersect, where do they cross, where do they meet, I've got to do the same thing for this line. So I need to know what is my m and my b. So again, your m is negative x, since it's just ax, a single x, that means your m is 1. It's negative, we keep it negative, and since we know we're going to graph it, let's go ahead and put it in a fraction for rise over run. So we have negative 1 over 1, and then your b is going to be a positive 2. So we're going to follow the same steps to graph this line as we did our first one. So we're going to start at positive 2, that's my b, that's my y-intercept. And now from here, we're going to use our slope to figure out what the rest of the points look like. So since this one's negative, I'm going to go down 1, but again, I still want to go right. So down 1, right 1, down 1, right 1, and now we've noticed exactly where my lines meet. So what we want to do is we want to indicate what is the solution to this system of equations. So that point, my x value is 1, and my y value is 1. So my answer is 1, 1. And if we wanted to refer to what Mr. Gossam did, he got the exact same answer. So again, it doesn't matter if you do it algebraically or if you do it on a graph, you should get an answer of 1, 1 either way. And now you know more.
Hey guys, it's Miss Garner. I'm going over the same problem that Mr. Gossam and Mr. Hart just did. Now that we have the solution, I'm going to plug it back into our original problem to make sure that it's right. So this is a way that you can check your answer to make sure you got the correct solution. So we saw that Mr. Hart and Mr. Gossam both got 1, 1. So we know our x is equal to 1 and our y is equal to 1. A solution to a system is where your two lines intersect. You can also think of it as the x and y value, where if you plug it into both equations, both of these equations will be true statements. So what I'm going to do is I'm going to plug in my x equals 1 to my x in both equations, and I'm going to plug in my y is equal to 1 into both of my y's. So if I start with my first equation, y equals 3x minus 2. My y is 1, so I'll put a 1 right there. 3x minus 2, I'll have 3 times 1, because my x is 1, minus 2. So I get 1 equals 3 minus 2, and we know that 3 minus 2 is 1, so 1 equals 1. That's a true statement. We know 1 is equal to 1, so we can put a check mark there. So we know the first equation, it's a solution for. We're going to do the same thing for the second one. So y equals negative x plus 2. Once again, I'm going to put in my x and y value. They're both 1, so I can put a 1 in for both of those variables. So 1 equals negative 1 plus 2. I know negative 1 plus 2 is positive 1. So once again, I get 1 equals 1. That's a true statement. So both of our equations hold true when we plug in the values x equals 1, y equals 1. So we know our solution of 1, 1 is the correct answer. So there are a variety of methods for solving system of equations, but going back and putting our values into your equations is always a way to check your answers. And now you know more.